In the last session, we have seen questions related to factors, right? In this session, what we are going to do is we are going to discuss about factorials. Let me go for a quick recap of what we have done in the previous session. So in factors, what all things we have discussed? So if a number can be expressed as a raised to m, b raised to n, you know how to find number of factors, right? So number of factors is actually m plus 1 into n plus 1. Then we have seen how to find sum of factors, right? And I have given you the formula for sum of factors, right? A minus 1 by a minus 1, b minus 1 by b minus 1, then this m plus 1 here and this n plus 1 here. That's it. Then we have seen product of factors, right? So that is nothing but the number raised to m plus 1 into n plus 1 divided by 2. That is nothing but the number of factors, right? Then we have seen how to find number of odd factors. What you will do? You will remove the 2. Then you can apply the formula of number of factors. Then we have seen number of even factors. Now once you know the total number of factors and how to find number of odd factors, you can find even number of even factors faster, right? Otherwise also I have given you the formula. In case of 2, you will drop the power just like that without adding 1 and then apply the normal formula of finding number of factors. So we are very clear with that also. So these are the 5 basic questions which can be asked from this prime factorization. Apart from that, we have also seen questions like odd number of factors. What are they? These are square numbers. Square numbers have odd number of factors. Then we have seen exactly 2 factors. Numbers having exactly 2 factors. What are they? They are prime numbers. Then we have seen exactly 3 factors. What are they? These are prime square numbers. Okay, so like this we have seen different patterns of question. Now if you take any cube number will always have 4 factors. Exactly 4 factors. Any cube number, if you take, the cube number will have exactly 4 factors. Let's take 27. It will have 4 factors. Why? Because it's actually 3 cube. Now, how will you write? 3 plus 1, 4. What are the factors? 1 is a factor, 27 is a factor, 3 is a factor, 9 is a factor. So these are the 4 factors. Then, if you take 125, what are the factors? 1 is a factor, 125 is a factor, 5 is a factor, 25 is a factor. So if you observe here, apart from 1, the factors are 5, 5 square and 5 cube. These are the factors. Now, in this session, we are going to discuss about factorials. Okay, so factorials. Now, what do you mean by factorials? Let's like this. 6 factorial is 1 into, 2 into, 3 into, 4 into, 5 into 6. So 6 factorial is nothing but the product of first 6 consecutive natural numbers. 7 factorial means product of 7 consecutive natural numbers starting from 1. Not just product of 7 numbers, it can be any 7 number, right? But when it comes to factorial, starting from 1, the product of consecutive natural numbers. Similarly, if I tell you n factorial, it is nothing but 1 into, 2 into, etc., etc. up to n. That's what n factorial, right? So what about instead of product, if I take 1, 2, 3, 1 plus 2 plus 3, then what is this? This is sum of first 3 natural numbers, right? We call it as sigma 3. If it is 1 plus 2 plus 3 plus etc. up to n, we call it as sigma n. So what is factorial? Product of first n consecutive natural numbers. What is sigma n? Sum of first n consecutive natural numbers. Now let's see the applications and let's see various questions from factorials in this session and sigma n in the next session, because sigma n is very interesting and the examiner used to ask questions from sigma n. Okay, so let's start off with questions from factorials in this session. What are the possible questions which can be asked? Like this. What is the highest power of a number? The first question which can be asked is highest power of a number in a factorial. It's like this. I give you and factorial, 100 factorial. It's a big huge number, right? I ask you how many 2's are there. I ask you how many 3's are there. I ask you how many 5's are there. So all these are prime numbers. I can also ask you how many 10's are there. That's a composite number. Or how many 12 are there. So I hope you understood, right? So how many 12 are there means what is the highest power of 12 in 100 factorial, or how many 2 are there means how many 2's are there means what is the highest power of 2 in 100 factorial, or the vice versa is the best way to understand. If I ask you what is the highest power of 2 in 100 factorial means how many 2's are there. If I ask you highest power of 5 in 100 factorial means how many 5's are there. I hope this is clear for all of you. Now let's see how to find it. Okay, that is the first question. Then I can also ask you how many zeros are there in a factorial. How many zeros are there in a factorial or in the end of a factorial or a product. Okay, how many zeros are there? So 100 factorial definitely will have zeros. How many zeros are there? So we all know zeros are depending on tens. So it depends on how many tens are there. So you basically need to find how many tens are there. So how many tens are there means I need to find the highest power of 10. And we are going to discuss the method for that also. Okay. Or they can simply give you a factorial just like this 100 factorial. How many factors are there? Anyway, a composite number which is given earlier, we know how to find number of factors, right? We have a formula m plus 1 into n plus 1 if you can prime factorize. So what you need to do, the given factorial, you need to prime factorize and you need to apply the formula, get the number of factors. So these are the possible questions. What are the questions? What is the highest power of a number in a factorial? That means how many times 2 is there, how many 3 is there, how many 5 is there, etc. in a factorial. Or I can ask you how many tens are there. Alternate question, how many zeros are there in the end of a factorial. Or I can simply ask you how many factors are there in this factorial. So these are the questions. Let's look into these questions one by one. Let's start off with the first one. What is that? Highest power of a number in a factorial. Okay. So the first question that we are going to look at is highest power of a number in a factorial. Okay. Now, highest power of a number. This number can be of two types, right? Prime number and composite number. So what we'll do is let's look at prime number first, and after that I'll discuss about composite number. So let's take a prime number 2 or 3 or 5, etc. For that matter, any prime number. So let's discuss the method for 2 first, then the same is applicable for all numbers. Okay. So now let me give you a question. How many 2's are there in 100 factorial? Okay. How many 2's are there? What does this mean? What is the highest power of 2 in 100 factorial? What you need to do is 100 you divide by 2. What do you get? You get 50. You divide this 50 again by 2. What do you get? 25. You divide by 2, you get 12. You divide by 2, you get 6. You divide by 2, you get 3. You divide by 2, you get 1. Now, what all things you got here? 75, 87, 93, 96, 97. You add everything, you got 97. What does this mean? 97 2's are there in 100 factorial. So how you are finding it? It's very simple. 100 factorial, how many 2's are there? You divide by 2 continuously where you get remainder less than 2, or till you get a number less than 2, and add all the quotients that you got. Okay. So if I ask you how many 5's are there in 100 factorial, what do you do? You divide by 5. That's it. That's the only difference. Then what do you get here? 20. Divide with 5 again. What do you get? 4. Now 4 is less than 5, so you can't divide, right? What is the answer? 20 plus 4, that is nothing but 24. So how many 5's are there? 24 5's are there in 100 factorial. How many 2's are there? 97 2's are there. We got it here. So if I ask you how many 3's are there, what you will do? You divide 100 by 3. Okay, you get 33. Okay, then divide by 3 again, you get 11. Then you can further divide by 3, you get 3. You divide with 3 again, you get 1. Now what you need to do? Add all those, right? 44, 47, 48. You add everything. So this is what you need to do. You divide continuously till you get a number less than the divisor or the given number. That is 3 here, right? So that's what you need to do. So I hope you understood, and this is the same method with any prime number. If it is 7, how many 7's are there in 100 factorial? Divide by 7. So what do you get? You get 14 here, right? Because 14 into 7, 98. Divide with 7 again, you get 2. So how many 7's are there? 16 7's are there. Now, how you are getting the 16 7's? If you need to see practically, see in which numbers you'll get 7. You get 7, right? Then all multiples of 7. So up to 98, how many multiples are there? 14 multiples of 7 are there. Then why 16? Because if you take 49, how many 7's are there? 7 and 7. If you take 98, it is nothing but 49 into 2. So that is also 7, 7 and 2. All other multiples have 1 7. but 49 and 98 is having 2 sevens each, so total you get 16 sevens, because 1 7 already counted here, this 1 7 also counted here, one left, that's why it is 16. So that's what you mean by highest power of a number in a factorial. Now here we find the answer for prime number, right? Now if I give you a composite number, let's take 10. So if I ask you highest power of a number in 100 factorial and I'm giving the number as 10, which is a composite number, what is the method? The method is similar to the previous one. You don't have a direct method for 10. You cannot divide with 10. What you need to do is convert this 10 to prime number. That means prime factorize 10. You will write it as 2 into 5. You will write it as 2 into 5, and that's your first step. What is your second step? Second step is find how many 2's are there. That means find highest power of 2. You know the method, right? What is the third step? Find highest power of 5. And you know 2 and 5 together will make you 10, right? Now obviously when you find number of 2's and number of 5's, number of 2's will be anyway larger than number of 5's. But the combination of 2 and 5 will give you 10. So effectively, to know what is the highest power of 10, you just need to know highest power of 5. I hope you understood. Because you already saw 97 2's are there and 24 5's are there in the previous explanation. When you are finding number of 2's in 100 factorial and number of 5 in 100 factorial, you got 97 and 24. But 2 and 5 together will make 10. So how many 10's you can get? Only 24. Because only 24 5's are there. 2's anyway more is there, but balance 2's is of no use. You can't make 10. You need 5 and 2 combination, right? So effectively, if you don't want to find this, number of 2's is not required. If I ask you how many 10's are there, you just need to find number of 5's. Because if number of 5 is 24, 2's anyway will be more than 24. I hope you understood this, right? So that is a way in which you can find the highest power of a composite number in a factorial. So what we have discussed? We have discussed highest power of a prime number in a factorial and highest power of a composite number in a factorial. Now, if I ask you highest power of 12 in 100 factorial, highest power of 12 in 100 factorial, what do you do? 12 is a composite number. So you write 12 as 2 square into 3, right? You write 12 as 2 square into 3. So you prime factorize like this, right? Then you need to find how many 2's are there. So when you find how many 2's are there, you divide like this. We have already saw this, right? So you get 50, you divide, you get 25, you divide, you get 12, you divide, you get 6, you divide, you get 3, you divide, you get 1. So when you add, you get 97. So 97 2's are there. But what we need 2 squares. So how many 2 square will be there? 48, half of 97. So 48 2 square will be there. Now let's see how many 3's will be there. Okay. So how many 3's will be there? Let's divide again 100 by 3. We have already seen this anyway. You get 33. You divide by 3, you get 11. You divide by 3, you get 3. You divide by 3, you get 1. So if you add here also, you get 48. So both are 48. That means what is the highest power of 12? That is also 48, because 12 is 2 square into 3. Now if I give you one more example, highest power of 15 in 100 factorial. Highest power of 15 in 100 factorial. What do you do? You know 15 you need to split as 3 into 5. Number of 3's you know 48. Number of 5's you know 24. So number of 15 in 100 factorial will be 24, because you will take the least power. Because 3 and 5 will give you 15. So 3's are more, that is useless. Okay, so only 24 3's you can take, because only 24 5's are there. So answer is 24. Now what is the next possible question? I can also ask you number of zeros in the end of a factorial or a product. Okay, so again let me give you 100 factorial itself. I ask you number of zeros in 100 factorial. What does it effectively means? Number of zeros means I'm actually asking you number of tens, right? So I need to find number of tens, or I'm actually asking you the highest power of 10. Now you know the method for this directly, right? Because this is a composite number. 10 you will have to write it as 2 into 5, right? Then how many 2's are there in 100 factorial? You know 97. How many 5's are there? You already know this is 24. So how many zeros will be there? 24. So whatever be the number, instead of 100 it can be 200, 300, 500 or whatever it is. Effectively you need to find number of tens. And when you need to find number of 10s, that is actually means you need to find number of 5s, because number of 2s will be anyway greater than number of 5s. Okay, so you don't want to find number of 2s, you just need to find number of 5s only. So number of zeros in the end of a factorial, it's nothing but number of 5s in that factorial. So if I ask you number of zeros in 15 factorial, you don't want to find number of 2s, you just need to find number of 5s. You can directly find just like this, right? So 5, you get 3. So how many zeros will be there? 3 zeros will be there, because 2s anyway will be more than this 3, right? Because 2 if you find, you get 7, again 2, that will be 3, again 2, that will be 1. So if you add, it is actually 11. So 2s anyway not required. We will hardly take only 3, we will take only 3 2s, right? Rest of the 2s are useless, so we just need to find number of 5s. So if I ask you how many zeros will be there in 56 factorial, just a random question, what do you need to do? Divide 56 with 5, so you get 11, divide with 5 again, 2, so 13, so 13 zeros will be there. I hope this is clear for all of you. 13 zeros will be there, or 13 tens will be there. In whichever language you need to understand, you can understand. Now, if I ask you to find highest power of 15 in 300 factorial, just a random question, what you will do? You will factorize 15, you will write it as 3 into 5. Then you don't want to find number of 3s, it's better to find number of 5s, because number of 3s will anyway greater than number of 5s, right? So 300 divide by 5, okay, you get 60, divide by 5, you get 12, divide by 5, you get 2, and 74 is your answer. Why you are not dividing with 3? The moment you divide 300 with 3, first you get 100. That itself is greater than 74, so that's not required. So 74 is the number of 15, because to get 15 you need 3 and 5. So 5s will be lesser than 3, so you just need to know number of 5s. Now, what will be the difficult question which I can ask you from here? I can ask you number of factors of a factorial, right? Number of factors of a factorial. Let's say 6 factorial. I need to find number of factors of 6 factorial. You know this is 720, right? 6 factorial is 720. So 720, what you need to do? You need to write it as prime number, or you need to prime factorize like this. You start dividing with 2 and you can do this. And then you need to apply the formula and you can find it. Otherwise, so basically the thing which I need to tell you, the point which I need to tell you is, even if it is factorial, the actual answer is a composite number. So if it is a composite number, definitely you can find number of factors, and we have the method. The problem is the number may be larger. That's the only problem. The point is you need to find and you can find. That's what you need to know. It's not that you cannot find. Okay, but 6 factorial, otherwise what is that? 1 into, 2 into, 3 into, 4 into, 5 into, 6. So how will you prime factorize? So you can get 1 2 here, there will be 2 2s here, there will be 1 2 here. So how many 2s? 2 raised to 4. Now how many 3s? 1 3 here and 1 3 here. So 2 3. Then how many 5? 1 5. So number of factors means this 4 plus 1 into this 2 plus 1 into this 1 plus 1, right? So 5 into 3 into 2, that's nothing but 30. So number of factors of 6 factorial is 30. 6 factorial is nothing but 720. So number of factors of 720 is 30. That's what you can understand. So if I give you number of factors of 8 factorial, if I ask you number of factors of 8 factorial, how will you do this? You can write it as 1 into 2 into 3, 4, 5, 6, 7, 8. This is what factorial. How will you prime factorize? See the possible number of 2s. You'll get 1 2 here. So 2 raised to 1. Then 2 2s here. So it become total 3 2s. Then again 1 2 here. So 4 2. Here you have 3 2s. 8 is 2 cube, right? So this become 2 raised to 7. So you got 7 2s from this totally. I hope this is clear for you. And how you are getting that? It's actually 8 divided by 2, you can see 4, divide by 2 again, you get 2, divide by 2 again, 1. So this is actually 7. How many 3s? You can do the same thing, 8 divided by 3, you get 2 here. Now why that 2 3s? In 6 you'll get 1 3, in 3 you will get 1 3, so it's actually 3 square. This is completely out, we have taken the 2's. This is completely out, we have taken the 2's. So this is also out, we have taken the 2 and 3. This is out, we have taken the 3. This is out. What is left out? 5 is left. Then number of factors will be 7 plus 1, that is 8. 2 plus 1, that is 3. 1 plus 1, 2. What if I ask you number of factors of 12 factorial? What if I ask you number of factors of 12 factorial? So basically you need to prime factorize 12 factorial in the similar way that we have done earlier, right? So if you prime factorize, you'll get 2 raised to 10 because 10 2's are there. If you want, you can do like this. 12 divided by 2. You get 6. Divide by 2, you get 3. Divide by 2, you get 1. Like this, you get 10 2's. Into 3 raised to 5, you can get 5 3's. You can see that you can factorize because 12 by 3, you get 4. 3, you get 1. So 5 3's are there. Into next prime number is 5. So 2 5's are there. 12 divided by 5, you can get 2. Okay. Into only 1 7 and 1 11. Everything else is covered. So what is your answer? 10 plus 1, this 10 plus 1, 11. This 5 plus 1, that is 6. 2 plus 1, that is 3. And 1 plus 1, that is 2 and 2. So 66 into 12. What is your answer? 660 into 132, right? So how to multiply this faster? 66 into 10, 660. 66 into 2, 132. So 792. 792 factors are there. I hope this is clear for all of you. So what all things we have discussed here? We have discussed about, we started with factorials and we have discussed about highest power of a number in a factorial, right? And we have seen in case of prime number and composite number. Then we have seen number of zeros in a factorial. Then we have seen number of factors of a factorial. So highest power of a number in a factorial, if it is prime number, you just continuously divide. If it is a composite number, make it as prime numbers just by prime factorizing. Okay, if it is number of zeros in a factorial, find number of tens in a factorial. I hope everything in factorial is clear for all of you.